It's exciting, isn't it? What about energy I see here today? Hello, everyone. I'm Shankar Ramamurthy, founder CEO of Virtual Power Systems. And with me here today, Ankush Dam, our VP of BizDev. Power is at the very core of your compute, storage, and networks in your data centers or your head-ends. And as you all well know, you run out of power first before you run out of cooling or space or anything else. So what we do at VPS is to help you avoid all these problems. Power is very expensive. It costs you tens of millions of dollars to build and to operate them. And we help you save this by using software-defined power. And what does software-defined power do? It basically optimizes power distribution within racks and across racks. And the key to this problem is you have over-designed, over-provisioned power in your data centers. There's a lot of fat. There's a small portion of this that you're actually utilizing. Fat number one, you have to provide for peaks. Fat number two, you have to have a lot of redundancies to make sure that you have power available when you have failures. Fat number three, you have all kinds of peaks that you have to provide for extended peaks, spikes, and then you have a lot of inefficiencies in your data centers, on your IT side. And what we do here is to basically cut the fat and turn this into muscle for your data center. So the first product, so we have a plethora of knobs, multiple control knobs that essentially knock out each one of these inefficiencies. Rack share, it intelligently manages a set of battery systems, very much like a hybrid car, across all your racks and shaves peaks and returns capacity to you. And source mix captures the power that is lost in redundancies. And we have source share that makes effective use of backup power generators and others that are sitting idle. And then you have load share that is orchestrating and working with the IT systems to return power back to you. Bottom line, this helps you you're spending hundreds of millions of dollars, $10 million a megawatt. And if you're going to be using ICE, Intelligent Control of Energy, our software, it would save you $100 million for even a 10 megawatt data center that you avoided building, and $7 million every year in OpEx. And translated this to what it means in terms of a total cost of ownership, it is $2,000 of cost saved per server. Think of what this means. The amount of IT initiatives that you can focus upon with the budget that got freed up. Ankush, you think you can show us how this magic works?
Sure, I will. So hi, everyone. What we're going to see is exactly how ICE enables you to add more IT workload to your existing power capacity. So here we have a typical 2N data center environment. It's actually a live environment running in our Bay Area lab. And you could think of this as your head-end environment, let's say. And it's a typical 2N dual-fed facility with 6 racks. So in this case, the math is as follows. You have 36 kW being fed from feed A, 36 kW kilowatts being fed from feed B, and then each rack is sized for 6 kW. So the issue here is that you have 36 kW reserved for redundancy. You can't actively tap into it because you need it for redundancy purposes in case of a power interruption. You could see and imagine that if you wanted to tap into this redundancy and add 6 more racks, you highly jeopardize the uptime of the facility in the case that there is a power failure. You're overloading the circuit, and you can't control those additional racks. So let's see how exactly ICE can kind of behave in this situation. I'm going to flip over to our ICE console, fire on dynamic redundancy, which is one of the control knobs that Shankar mentioned earlier. And I'm going to simulate a failure of the main utility feed, let's say feed A in this circumstance. And what we should see is that the high priority racks in red, the 2N racks, stay on. The medium priority racks in yellow maintain uptime. And the least critical racks, the lowest priority racks in black, are actually throttled back a bit by just amount of the power deficit. So let's fail feed A. Within 10 milliseconds, what you're seeing here is that all of the racks in red are maintaining availability. You can see the B side is doubled in power capacity and maintaining that rack. And the least critical racks in black have actually been throttled back by just the amount of the deficit. So, you know, what this means is that now you can safely, effectively, and reliably add up to 36 kW more of servers within your existing power capacity. Shankar, do you want to show an actual customer use case?
Yeah, that's a good idea, Ankush. Thank you. So let me actually take a customer use case back to the presentation of an edge data center. So this edge data center has 5 megawatts, wanted to add another 10,000 servers, reckon about 200 kilowatts a server, that's about 2 megawatts. So they're going to have to add 2 megawatts, which means they would have to build a new data center for 2 megawatts. It's going to take a few years. They have to provision about $20 million in CapEx and about $1.4 million or so in OpEx every year. But with VPS, you're saving about $10 million or $12 million. And on top of that, you're also saving about $1 million every year in terms of OpEx. This translates to about $1,500 in savings in total cost of ownership per server. Do you think it's compelling? Come and see us at the Tech Stadium, booth number 5. Thank you.